So we can start. Okay. Then I need to stop sharing that. I will share the paper. Okay. I'm sharing the wrong thing. There we go. Okay, so you writing 2-hour exam paper. I don't know the format of the online exam, how it looks, but I'm going to make an assumption that it looks almost exactly the same as if you're going to write in a venue. You will have 2 hours and it is out of 100 marks, and there are about 25 questions or 24. So let me see how many questions are in this one. They are, yes, 25 questions. So it means each question weighs 4 marks in your exam. So since you're writing an online exam as well, so you can make notes on the side from chapter 1 to from study unit 1 up until the last study unit, which is time series. You can make list of the formulas that you need to know about your module for each section, and you can also make notes for yourself, because then it's almost like it's an open book, so you can have all that information in front of you when you write your exam, so that then you don't scratch around. And then you can also have another especially your tutorial letter 101 open close by next door, so that you can always use it for tables. If you don't have hard copy material, then you will have your other like tutorial letter 101 open somewhere where you can always use to refer or reflect in terms of your tables and have them ready for you, because you're going to always constantly come here and look at the tables, look for the critical values, or to look for mostly the critical values or the probabilities when you're calculating the probabilities. Okay, so without wasting any more time, let's get into it. Question 1 was asking that 2 sample sizes of 25 and 35 are independently selected from 2 normal population where the unknown population variances are assumed to be equal. So here we're talking about unequal population variances. In order to test the difference between the population means, the test statistic will be, number 1, it says it will be a standard normal random variable. 2, it will be an approximately a normal standard normal random variable. Your test statistic will be the student T distribution with the degrees of freedom of 58. The other one says the student T distribution with the degrees of freedom of 57. And the last one is the student distribution with 60. So which one will be the correct one?
Number 3.
Number 3. Why number 3? So we know that we're doing sorry, I'm trying to get my pen out. We know that the population standard deviations are unknown, variances are unknown. Therefore, it means we're going to be using a t-test statistic. And if we're going to be using a t-test statistics, the degrees of freedom is given by N1 plus N2 minus 2. Our N1 is 25 plus 35 minus 2. And the answer here is 60 minus 2 is 58. And that is why 3 will be the right one. Question number 2. Given the summary statistic for the independent variable samples from 2 populations, which are normally distribution, and they give us the sample 1 and the sample 2 with their own statistics values, which is the sample mean, the population standard deviation, and your sample size. And the researcher wants to determine whether the estimated mean of sample 1 is more than, and since they say it is more than, therefore it is a one-sided test. Which one of the following statement is incorrect? Number 1, is it correct or incorrect? Based on this information, is this a one-tailed test or a two-tailed test?
Yes, it's a one-tailed test.
The one-tailed test. What are we going to be using? Are we using a pooled variance or not? A pooled variance t-test.
No, we're not using a pool.
We're not using a pooled variance t-test because our population, since they give us the population standard deviation, therefore it means we're going to would have used the Z. So then it means our incorrect question was option number 2. We don't have to go through all of them. Because by looking at all of them, we can see that they are all using the Z. And this one was saying how you make a conclusion or the decision. But since they said here we're using a t-test, it will be the wrong one to use. Okay, so question number 3. Suppose that we want to decide whether the mean salaries of staff members in the private institution is also here. It says less than the mean salary of staff. So it means we're still doing a one-tailed test. And this is from the independent samples are shown below. And here they give us the sample size, the sample standard deviation. They give us the sample mean of 88, the sample standard deviation of 26, and the sample size of 35 for sample 1, and they also give us the statistics for sample 2. That the population variances are equal. Which one of the following statement is incorrect? The first one, it says the null hypothesis states that the mean 1 is equals to mean 2. Is it correct? Remember, in your null hypothesis, there is always going to be an equal sign. And with that, therefore, it means that statement would still stand. It will still be correct. The alternative, looking at what the question said on the alternative, let's look at the question. The question said it is less than. And what is less than? Less than looks like that. So the alternative says that the mean one, the mean the private institution is less than the mean salary of the public institution. So the mean of the private institution is less than the mean of the public institution. So since it says less than there, therefore this is also correct. The standard error for this, what will be the standard errors? The standard error will be the square root of the pooled variances times the square root of the pooled variances times 1 over n1 plus 1 over n2. And remember, the pooled variances is n1 minus 1 times the variance of 1 plus n2 minus 1 times the variance of 2 divided by n1 minus 1 plus n2 minus 2. So the standard error, we first need to calculate the pooled variance, which is n1 minus 1 times S12. Is it plus or minus?
It's plus.
Plus. It's a plus, so it will be n2 minus 1 s squared 2 divided by n1 minus 1 plus n2 minus 1. You need to calculate that, and once you've calculated that, then you will calculate the square root of the SP spooled variance times 1 over n1 plus 1 over n2. So you will substitute that spooled variance value into this formula. Do you get the same answer? What is your answer? And this is where I said you need to work through this exam papers outside of this session so that then we can look at the questions and see if you get the different answers. So since you didn't do that, then we're going to sit here and work them out. N1 is 35.
Option 3 is correct.
Okay. Michelle, do you agree? I was still calculating the spoon variance. took me longer to get there. Wait a bit. Michelle?
I have answered on the chat.
Oh, I'm not looking at the chat. So the spoon variance is 634.78 and a whole lot of numbers. And when you substitute it into that, the answer will be 6.
Hi, yes, I agree. It is correct.
Yes, so that when you substitute, the answer will be 62687, some number there, which means that is correct. Is this a one-tail test?
Yes, it
Yes.
is.
Less than, therefore that is a one-tail test. For the confidence interval, it says it falls between 2.7 and 2.70. So therefore it means you will have to go and calculate the confidence interval to see if that is the incorrect one. But by the look of things, I would have selected confidence interval of that because it says here at 95%. So you will need to go and find the critical value and do the calculations. So since we know that option number 1, 2, 3, and 4 are correct, so we don't even have to go and do the confidence interval calculation. Otherwise, you can go look at the confidence interval. The formula to do that will be your mean. Is it mean 1 or mean 2? Mean 1 minus mean 2 plus or minus the critical value of alpha divided by 2, and this times the standard error. So mean 1 minus mean 2 plus or minus T alpha divided by 2 and the degrees of freedom for this. And we know that the degrees of freedom is N1 plus N2 minus 2. So that will be your degrees of freedom times the standard error, which is your square root of your spool variance times 1 over N1 plus 1 over N2. And you already calculated this. We find that it was 6.2. So you just substitute there. You just go and find your critical value on the table and then subtract 88 minus 73 and calculate and see if you get those two answers. But then will mean this was supposed to be our incorrect answer. Okay, so let's go to the next one. So it's question number 4. It says the null hypothesis is stated by the mean is equals to the mean of population 1 is equals to the mean of population 2. The alternative says they are not equal. We have been provided with the data, and this is a simple random paired sample from 2 populations under consideration. In each case, use the paired t-test to perform the hypothesis test at 1% significance level. So here we are asked to find the critical value, not to go and find the other things, but here we just want to find the critical value. How do we find the critical value of the paired test? The critical value is because it's a two-tailed test, we're using a t-test. So we go and find it using t alpha divided by 2. Maybe I should write it close by. Yeah. So it will be t alpha divided by 2 because we're doing a two-tailed test. And the degrees of freedom will be n minus 1 because we're going to use the difference because it's a paired test. And since it's a paired test, we use only the differences to calculate. So you go find the critical value. How many do we have? We have 7. So this is at alpha 0,01. So you will say t 0,01. And your n is 7 minus 1, which then gives us t of 0.01 divided by 2 is 0.005 and 6. And then you go to the table, the critical value table. We're looking for the critical values of t. So we go to critical values of t table. And this is the critical values of t. We look for t 0,005, which is the last column. And we look for degrees of freedom of 6, where they meet. That is your answer. Agree?
Yes.
Being option number 4.
Yes.
Using the same information from above, consider the information above with a 99% confidence interval. So it's still same because our alpha here will still be 0,01. So since we're doing a two-tailed test, we already found the critical value, so we don't have to go find the critical value again. Here is the critical value. We just need to have the sum of all these values. We need to calculate the mean, which is the sum of the differences divided by how many there are. You do that. Once you have calculated the mean, then we need to calculate the confidence interval. Then you also, sorry, not only the mean, but you also need to calculate the standard deviation, which is so you calculate the mean, and after calculating the mean, we need to calculate the standard deviation, which is the square root of your observation, your differences minus the mean difference squared divided by, do we divide by, sorry, I need to go to the formulas. I'm thinking now I know these things by heart, sorry, because this is the tutorial letter. It's not gonna have formulas here. But usually your exam paper will come with formulas. I don't know on the online platform if they will give you formulas like that. But they will supply you with formulas, and it will be n minus 1. So you need to calculate that. Remember, you can also use your calculators. I don't know what kind of calculators you have. You can use your state mode on your calculator to calculate the mean and the standard deviation by putting your calculators to state mode 1, mode 0, which is the SG, and then capturing the information. And your mean, I hope I am right. I have calculated it. It's 2.571. Well, because my calculator is in. And then if I calculate my standard deviation, and the answer here I get is 2.2254. Do you get the same?
Yes.
Okay. So now we come to, we're going to calculate the mean plus or minus our critical value, T alpha divided by 2 and the degrees of freedom. We've calculated it. You just use the value you calculated there, multiply by the standard error, which is your sample standard deviation divided by the square root of n. So based on the values we had, remember our mean was 2.5714 and our standard deviation was 2.2254. You just substitute into the formula 2.5714 plus or minus our critical value was 3.707. 3.707 times our standard deviation, 2.2254 divided by the square root of our n, which is 7. Are you winning? Okay,
Option
I'm not
5
going
is the correct
It's
one.
option number 5 because the question I'm using my Casio calculator, it makes it easy. 0.5466 and 5.6894, which makes option number 5 the correct one. So you just need to calculate. Okay, so 30 minutes, 5 questions. You. We left with 1 hour, 30 minutes. So it means by the end of the session, we'll have only covered 20 questions. So let's see, maybe some of them might be as quick as possible. Consider a hypothesis testing for 2 populations with the null hypothesis that says the proportion for population 1 is equals to the proportion of population 2. Given this information, there are X number of successes, which are 10, and for the other population is 18. The sample size for independent random sample is n is equals to 20 and n is equals to 30 for n2. Use the data above to determine whether the percentage of the population 1 is more than. So since they say more than, it's a one-tail test. Okay, so since we know this is the null hypothesis, what will be the alternative hypothesis based on this information we have? More than would have been this equal, greater than, because it says more than. We're looking for the correct one. So is number 1 correct?
No.
Number 1 is not correct. And then number 2, what will be the sample proportions? So remember your proportions. So P1, we can find it by using X1 divided by N1, and P2, we're going to find it by using X2 over N2. Is option 2 correct? This will
No.
be 10 over 20, and the other one will be 18 over 30. So you're saying this is not correct, because 10 over 20 will give us 0.5 for P1. The Z test statistic, is this going to be a Z test statistic since it's proportions? Is that correct? Yes, it will be correct, because for proportions, we always use the Z statistic. So that will be correct. Always, for the proportions, we always use the Z statistic to calculate. Then we don't have to go and try and do question number 4 and question number 5, because if question number 3 is correct, that's what we were looking for. Otherwise, if you wanted to calculate what the pooled variance or the pooled proportions would have been, the pooled proportion, I hope I'm going to have the correct formula here. The pooled proportion will be your X2 divided by N1 plus N2. That's the pooled proportion. The standard error, you can calculate it, because it will be the square root of your pooled proportion. So your standard error would have been the square root of your pooled proportion times 1 minus your pooled proportion times 1 over N1 plus 1 over N2. And that will be your standard error. And if you calculate that, they will give you that answer. So 28 divided by 50 equals 50. No, that will be incorrect because the answer for that 10 plus 18 is 28 divided by 20 plus 30 is 50, gives you 0.56. 0.56. Therefore, that will be incorrect. And if that one is incorrect, therefore it means the standard error will be definitely be incorrect because it says it's 0.56. The standard error, if you calculate, it will be 0.65. Okay. So that would have been also incorrect. So the only correct answer here will be option number 3. Will be option number 3. Okay, so we go to question 7. Happy?
Yes.
Yes. Great. So we go to question 7. It says, given the information on question 6 above, the 95% confidence interval for the population proportion is. So now, oh gosh, so you needed to calculate the standard error because now we need to use the information from the previous question to calculate the confidence interval. And your confidence interval will be your population proportion 1 minus the population proportion 2 plus or minus Z alpha divided by 2. Because it's proportion, we're always going to use the Z alpha divided by 2. Here it means our alpha is 0.05. Therefore, it means our critical value for this, which will be given by Z alpha divided by 2, it will be 1.96. You should know this by heart. But for a 0.025, because it will be Z of 0.0250 when we divide 0.05 by 2. And remember, you can go and find the critical values. If you go down to the table, there is a critical value. There is one last table there. Here we go. So for Z 0.025, our critical value will be 1.96. So you will substitute the 0.0196 times the standard error, which is the pooled variance times proportion 1 minus the pooled proportion times 1 over N1 plus 1 over N2. We will need to go and calculate that. And since I took a shortcut and not calculate the standard error, so let's go and calculate the standard error. Remember that was 0.56 for the pool times 1 minus 0.56 times And the standard error is 0.14. Zero comma 1432329 and some odd numbers. You can write all of them up times 1.96 plus or minus our proportion 0.5 minus 18 divided by 30. 0.6. And you can solve that.
It's option 3.
And the answer here will be option number 3. It's 0.380. They have 7, I have 8. And 0.1808, they have all 7. Okay. Oh. Okay, so that's that. Yes.
They just rounded down.
Yeah. Or they didn't keep all the digits when they were calculating. They kept it to 2 decimals or 3 decimals, and I kept it all. Yeah. Okay. Right. So now we move into question number 8. Question number 8, given the information, I'm not going to read the whole statement. At 5% level of significance, do the data provide sufficient evidence to conclude that the population variance is more than? And it's very important that you read the sentences correctly so that you don't make wrong assumptions when you do the calculations. So all this, they help in terms of knowing whether you're doing a 2-tailed test or a 1-tailed test. Which one of the following statement is incorrect? And here we're dealing with population variance. And these are so what will be the degrees of freedom for pH? The degrees of freedom is N1 minus 1. So how many do we have for pH? N1 is N1 minus 1. So we have 10 minus 1. We're looking for the incorrect answer. So this is correct. The degrees of freedom for control will also be N2 minus 1. We have 25 minus 1. That will be correct. And since we're dealing with the variances, the population variances, is this going to be a Z test or an F test or a T test? It will be an F test because we're going to use S1 divided by S2, the variance. I hope that is the formula. We use the variance of population 1 divided by the variance of population 2 to calculate the test statistic. So it will be an F test, definitely. So, okay. Are we doing a one-tailed test or a two-tailed test? Based on the information I just highlighted, I underlined.
One tail.
It's a one-tailed test, so therefore this is going to be incorrect. Otherwise, you can go and check what the critical value is. When you go check the critical value, remember your critical value, since we're doing an F test, it will have been F alpha, and the degrees of freedom, which we have V1 will be equals to 9, and V2 will be equals to 24. And you will go to the F test table, which looks like this. We'll say the critical values of F distribution, and you go look for alpha value. So in terms of what we are answering, they gave at 5% level of significance, and therefore you just leave it at there. So that will be your alpha of 0.05, and you will use this table. At the top, you will find your degrees of freedom for 1, which was 9. And you will go to the bottom and go find the degrees of freedom for 24, where they meet. That will be your critical value. To date. And you can see that that was to date. And that's how you find the critical values. Okay, so that is that. Going to the next question. Question 9. Also, we're still in the population variance. It asks, suppose that the analyst wants to test the hypothesis that the variance are equal or the variance are not equal. So we're doing a two-tailed test. So there will be 2 regions of rejections. At alpha of 0.05, therefore it means we're going to find our alpha at alpha divided by 2 because it's a two-tailed test. Which one of the following statement is correct? Finding the critical value. So I've shown you how to find the critical value. So find the critical value with V1 and V2, knowing that V1 is N1 minus 1, that's V1, and V2 it's N2 minus 1. And once you found that, you do alpha divided by 2, which will give you your F of 0.005 divided by 2 will be 0.025. And the degrees of freedom of 12 minus 1, which is 11, and N2, which is 27 minus 1, which will be 26. So you go look for F 0.025, we go look for that. So now this is 0.05, so we need to look for the one that says 0.25. I'm not gonna turn the page, I'm just gonna scroll the way it is. This is still 0.05. We'll look for 0.025. There we go, 0,025. Remember the values, 11 and 26. At the top, we're looking for 11, which is the last column. And at the bottom, we're looking for 26, where they meet. And that will be your critical value, 2,54. We're looking for the correct answer. 2,54, that will not be the correct one. The region of rejection, here it says, it gives you the right values. And it says the region of rejection will be in the 2,54. Looking at the question, we know that this is always going to be a one-sided test, something like that. So it means that will be correct. This is only based on the information that we have there, because we only have one region of rejection, even though we're looking at the two-tailed side. So this will be the correct one. Otherwise, you can go and find the question. Did I close the tutorial letter 101? Why is it not showing here anymore? Sorry. Something moved out of the presentation side. Which one is still in the presentation?
That's the tutorial 101 is still in the presentation.
It's still in the questions are no longer there. So I want to bring them both together. Just give me some time to bring it back in. Do you see that? Now do you see both?
Yes.
Okay. Something went wrong there. Okay, so you can go and calculate your, oh, sorry, I wanted to demonstrate why I'm saying this is the correct region of rejection. If you look at the graph, it shows you where your region of rejection is. Always going to be a one-sided test. For this, so we're going to have the region of rejection there. It's one side, and that is why it's also that way. So if okay, so for you can go and calculate your F test as well, and you can go find the confidence intervals. Okay, so question number 10. A partially, wait, sorry, my bad. Wait. So this should be greater than, because it's on one-sided test. Because if it's less than, we do not reject. If your test statistics falls in this side, we do not reject the null hypothesis. If it falls this side, we reject the null hypothesis. My bad. We need to go back to question number 9. We did it all wrong. So this says it is less than. So it should be saying it when it's greater than. If the region of rejection will be on the greater than side, not the less than side. Sorry, my bad. So that will be incorrect. So we need to go and calculate the F test. So calculating the F test. Sample variance for 1 divided by sample variance for 2. So you just substitute the sample variances. There they are, it's 3.8. Remember, if they didn't give you the sample variance, they would have given you the standard deviation, and then you will take the square of those answers. 3.87 divided by 8.75. 3.87 divided by 8.75 equals 0.44, and that should be the correct answer. Number 3 should be the correct answer. Otherwise, you can go and look for the upper limits and the confidence intervals by finding the confidence intervals. We'll need to find the formula. If the formula is different, I just need to go down to the bottom to just show you how to find the confidence intervals. Sorry. There we go. So you will use this formula to go find the upper confidence interval and to go find the lower confidence interval. I know we didn't touch this in class, but in the exam, you might be asked to do this, like we see there or there. So you will use those two formulas to go find the confidence intervals. They look different, so make sure that you apply the correct formula. I'm not going to touch on that. Also now, we're going to move to question number 10. 10. Oh, not 10, 9. Is it 10 or 9 or 10? Okay, 10. So question number 10. On question number 10, what you can do is to complete this table as well, well in advance before you can start answering these questions. So you need to also know the degrees of freedom for every one of them. So we know the degrees of freedom for treatment. Degrees of freedom for treatment is your number of groups, which is C minus 1. So this will be C minus 1, and for error, it will be N minus C, and for total, it will be N minus 1. So those will be your degrees of freedom. So now, if we know that those are the degrees of freedom, and we know that this is the degrees of freedom of 41, therefore it means the total N would have been 42, right? N is equals to 42. So if N is equals to 42, if we say N minus 1, so it will be 42 minus 1, it will give us 41. Therefore, if we need to calculate what C is, what do you call this now? Your error, degrees of freedom, we need to know what the total groups are. So we know that C is calculated using, the degrees of freedom for treatment is calculated using C minus 1. Therefore, it means if we add 1 there, we will know what the value of C was. So C was 7. So since we know that C is 7 and N is 42, then we can calculate the degrees of freedom for error, which will be 42 minus 7, which is equals to, how much will it be equals to? 42 minus 7 equals 35. And that means that one will be equals to 35. And then you can come and answer all these other questions. So we know that the sum square measure for error is calculated by, we don't even have to go and find that. We can just calculate it by saying 46.5 minus 17.5. It should give us that value there, the sum square of the error, which also we can, if we want to calculate it, but it might not be as simple as that, because it will be SSW divided by, not SSW divided by that. It will be the sum of your X observations minus your mean, and we don't have that information. Alternatively, because these are totals, we can just calculate them this way. The same thing happens here. We could have just said 41 minus 6, it would have given us 35. If you take 41 and you subtract 6, it will still give you 35. So for this, you could have just said 41 minus 6, it would have still given you 35. I did it this way because some of the questions here we need to answer uses all that information. The MS sum square measures, so we know that MS, so this should not be MST, but it should say MSA. So we can use the terminology MSA for this, which is your SSA divided by your degrees of freedom, which is C minus 1. And we know that our SSA is 17.5 divided by the degrees of freedom of 6. And you can calculate that. Your F statistic, you need to calculate also the MSE. So calculating the MSE or MSW in this instance that we can call them. So our MSW, which is the errors, we calculate it by using SSW divided by N minus C, and we calculated that. What did we get? 46.5 minus 17.5 equals 29. This is 29, which goes, this is 29. So this is 35. And this will say 29 divided by our NC, we calculated it, it was 35. And you can complete these questions. So let's answer the questions because I'm not going to do all the calculations for you. So we're looking for the incorrect answer. The number of treatments, which are the number of groups in this, are they 6 or 7?
Seven.
There are 7. So this would have been the incorrect one. And since the question is asking for the incorrect one, and that would have been your answer. And if I browse through this whole question, you would have calculated your mean square measure, which is the MSA for treatment, which is that to answer option 3, 17 divided by 5, 17.5 divided by, 17.5 divided by 6 is 2.96. So this would have been correct, that would be correct. And also if you take 29 divided by 35, it will give you 0.82, that would have been correct. And if you calculate your F statistic, which is your F stat, will be given by MSA divided by MSW, which is 2.9167 divided by 0.8286. And if you calculate that, you will find that that is correct. And that is 3.52. And that is correct. And that's how you will answer that. So, okay, 10 questions, 1 hour to go. Referring to the question above, which is the same as what we have calculated, what will be the critical value? Finding the critical value. Remember the critical value, we find it on the table. The critical value, we're going to use alpha since we're having 1 degrees of freedom, 1 rejection area, we'll use alpha, and you're going to use your degrees of freedom. Degrees of freedom for 1, which is C minus 1, and N minus C. So, so for this, you're going to use F alpha and degrees of freedom for 1 and degrees of freedom for 2. We know that the degrees of freedom for 1 is N is C minus 1, which was 6, and the degrees of freedom for 2 is N minus C, which is 35. And if we look at this, our alpha is 0.025, and our degrees of freedom of 6 and 35. So we go to the F table. We look for 0.025, which is the one that we are at. We're looking for 6 for degrees of freedom 1, and we're looking for 35 for degrees of freedom 2, where they meet 2.80. 2.80. Happy?
Yes.
And that is how you find that. Okay. Going to the next one. Using this table, already the table is calculated, everything completed, and this is the block, the ANOVA randomized block design. So go to the question, and remember the null hypothesis will say all the means are the same. So question, we're looking for the incorrect one. So question number 1, it will be correct. And number 2, the statement will say at least one or at least some of them are the same, are different, and therefore that will be correct. Then we need to find the number of blocks used. So how will you know the number of blocks? If I can give you the degrees of you need to know the degrees of freedom. Actually, the degrees of freedom for blocks is, let's see. The degrees of freedom for blocks is number of blocks minus 1. So the degrees of freedom for blocks will be number of blocks minus 1. For treatment, it will be number of groups minus 1. And for the error, it will be number of block minus 1 times number of groups times 1. Now this will be C minus 1 times R minus 1. Okay. And that's so how many number of blocks would we have? So if R is our number of blocks and we have blocks degrees of freedom is 2. What will be the number of blocks? The number of blocks will have been 3 because we're going to say R is equals to 3 and 3 minus 1 will give us 2. So that is incorrect. And at the bottom, it also says the number of number of treatments used is 5. We know that the number of treatments, which is C, would have been 5 because 5 minus 1 would give us 4. So that would have been correct. And the number of observation collected, remember that will be the total, not this total, but this is N minus C. So this will be R times C minus 1 which is total number of, so the total number of observation would have been R times C. So our R is 5 times 3, which will be 15. So we know that the degrees of freedom for total is RC minus 1. So it would have been 15 minus 1, which will give us 14. So if I look at this would have been correct as well. So the only option that is incorrect is option number 3. Okay, so question 13. Given the null hypothesis of that from the population, and we are given the frequencies, and this is a goodness of fit test. So we need to determine whether the distribution differs. So here we're looking at chi-square test. So with chi-square test, for goodness of fit test, remember, we need the observation minus the expected. So it means if they have given us the observations, we can calculate the probabilities. So they've given us the probabilities as proportions in the hypothesis, because they say the hypothesis, in the null hypothesis, it says the proportions are the same. They are like proportion of 0,1 is equals to this, and the proportion of 2 is equals to that, and blah, 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 blah. Now we need to calculate the expected. Remember how we calculate the expected? We take the proportion multiplied by the frequency. So we take 39 multiplied by 0,2, 39 multiplied by 0.2, which gives, sorry, my bad, not that. So we multiply the proportion by the sample size. Sorry. Our sample size is 100. Is it 100? We need to add all the frequencies to get the total. Sorry, my bad. We need to calculate first the total. So the total is 39 plus 78 plus 64 plus 19, which gives us 200. So our total is 200. So we say, so here it says the N is 100. So that will be incorrect. Sorry, we're looking for the correct answer. And then to calculate the proportion, we say 0.2 times 200, which is to calculate the expected frequencies. We say 0.2 times 200 equals, and that gives us our expected frequency. Then we continue and do the second one to make sure that we get the same. 0.4 times 200 should give us 80.3 times 200 gives us 60.1 times 200. It gives us 20, and those are our expected frequency. So therefore, That is correct. We can stop right there, or you can continue and calculate this. So I'm not going to continue and calculate everything. You can do it on your own time. And this is one of the exercises that we did in class as well. So you can also go double check, because in class we did it in detail when we did the chi-square test. So you can go and look at how we solved the same question. So the answer is option 2. Moving on. Suppose that, now we move into the question 14. It says, suppose that the bivariate data are to be grouped into a contingency table. So remember, if we have a contingency table and it says the degrees of freedom is that, so a contingency table will give you the number of rows and number of columns. So the question says, the number of degrees of freedom if the rows, so we know that for this, the degrees of freedom is given by the number of rows minus 1 times the number of columns minus 1. So it says if the rows are 2, so it will be 2 minus 1, and the columns are 3, it will be 3 minus 1. What will be the degrees of freedom? It will be option number, because this will be 1 times 2, which is equals to 2. And that will be option number 2. Option number 4. And that's how you will calculate your degrees of freedom. Questions? Happy?
Yes.
Yeah. So we go to question number 15. And I think also this one we did it in class, but I'm not sure. We can just do it. Here they give you the contingency table with missing information. So I'm not going to ask you to go through all the missing information, because we also did some of this in detail in class. We completed the table and then and answered the questions because we had enough time. So here we're just going to go dive in, because it says hint, complete the missing information. So it's best to complete the whole table before you start answering the questions. But since we're running out of time, I'm not going to do that. We're going to answer the question based on what we have. So, but in your spare time, try to complete the whole table first before you do this. It will save you a whole lot of time. Remember, it's contingency table or chi-square test. So it says null hypothesis will always state independent. The alternative will state dependent. So null hypothesis, independent, which makes this the correct statement. We're looking for the incorrect one. Alternative, dependent. That is correct. Since in your null hypothesis, if it's independent, so your alternative will be dependent. Always, always null hypothesis states independent. The number of 8 cases that were white females is 1,971. So these are observed values. So they're saying the white females. So we're going to look at race, white, and female. So which is this missing information. You see how important it is to have completed the table. So you can calculate this by saying 12, 534 minus 10, 63, 653, which is equals to 1,881. So this is incorrect. So we already have our incorrect answer. You don't have to continue and looking at all of them. But here it says the Indians, so it means the total of Indians. They're looking for this question, the answer for that one. So you need to calculate all the values so that you can have total of Indians. And then
Sorry.
here it says, yes.
Sorry, can you redo that one?
12,
Please.
Which one?
The white females.
Oh, sorry, I did it all wrong. I see. You are right. My calculation, I swapped the values. I did 10, 6, 5. So it is 12, 5, 3, 4 minus 10, 5, 6, 3. Sorry, my bad. It is correct. It's 1. Yes. Don't always rely on my calculations because I'm doing it hash. You must always double check my calculation. So this is 1971. Okay, so this is correct. So the total of Indians, you need to calculate that total there. So the best thing to do is to calculate this one first, because you have that information and that information for males and females, for blacks. So you just say 14,247 plus 7196. Please double check my answer. I get 21443. For blacks, total for blacks. Do you also get that? I can double check.
Yes.
14,247 plus 7196 equals 21443. Now add, say 42,496, because we take the grand total. We're going to subtract that value and subtract that value so that we can get the value here. 42,496 subtract 21, subtract 21443, subtract also 12,534 equals 8519. 8519. 8519, that is correct. So we need to calculate the expected frequency of black male, black and male. They are not making it easy. So we need to find this total. So black male, we need to calculate total for male, which is 10,563 plus 14,247 plus 6471 equals, what do you get?
Uh, 31,281.
Okay, I also get the same. $31,281. So now we need to calculate the expected value for black males, which means we need to say row total multiply by column total divide by n. Our row total for black is 21443 multiply by column total for male 312181 divide by the overall total, which is 42496. What do you get? I doubt if you will get 14,947.
15784, 0381.
Yes. Therefore, that is incorrect. Okay, so that is question 15. Yeah, it's 5 questions per hour, per 30 minutes. So I hope in the exam you will catch up on time as well. Because it's taking us long. Or maybe because we are doing a lot of discussions as well. In the exam, you just be working out. So we're given a table. So still, this is also contingency table. And what are they asking us? At 5% level of significance, do the data below, is it sufficient to conclude that the residents of red, blue, black, yellow states are homogeneous with respect to their views? So now here is more like they're asking you what is chi-square test asymmetric. So if you don't know what symmetric is, it means it follows a normal distribution shape. If you don't know what chi-square test looks like, then you can go and look for a chi-square critical values of chi-square, which is this, and you can look at this. Is this looks like normal distributed table? No, because a normal distributed distribution will look somehow like this. Mine is not nice, but it will. That's symmetrical. Even though it's skewed, but it should look somehow like that. So if you look at this compared to that, this is not symmetrical. So we're looking for the correct answer. That will be incorrect. Chi-square test is performed when the hypothesis is compared. A chi-square test is performed when the hypothesis is to compare the distribution of variables of 2 or more populations. Nope, we're comparing the variables, 2 or more variables. So if you look at this, it's not by population, but this is one population. We're looking at the categorical data. So this is also not correct. What will be the critical value? So remember, critical value. For this, we will find the critical value of F squared using alpha and your degrees of freedom. The degrees of freedom is your number of rows minus 1 times the number of columns minus 1. How many number of rows do we have? 1, 2, 3, 4, excluding the total. So we have 4 minus 1 times how many number of columns? We have 3 minus 1, and our alpha in this instance is chi-square of our chi-square of 5% is 0.05. So 0.05. So here we have 3, and here we have 2. So 2 times 3 is 6. So we have the chi-square test. We're looking for 0.05 and 6. Where they meet, that is our critical value. And the critical value is 12.6. Going back to our question, it says here the critical value is 16 points, which is not correct. Now we need to calculate the expected frequency of red and stay same. Red and stay safe. That is that we calculate the expected value of red and stay safe. Row total multiply by column total divide by n. What is our row total for remain the same? 488 multiplied by column total of red, 500. Divide by the grand total, 1,500. Calculate that.
So 162,66667
Is
162,6 recurring
that the
7.
correct one? Yes, that will be the correct one, and you can go on and look at whether that one will be correct or wrong. So since we have to make a decision, we know that our critical value here was 12,6. Our 16, it falls here, so we reject the null hypothesis. So here it says we fail, so that will be incorrect. Okay, question 16. Question 16 is linear regression. So we know with linear regression, this is the equation of a straight line. And always we need to know that our x represent independent variables. So that is not correct. And our y will be our dependent variable. That is not correct. We're looking for the correct answer. Now, in terms of r closer to 0 indicates that there is extremely useful predictions. So r closer to 0 means that there is no relationship. So this means incorrect. So we already know that. A value of r closer to 1 indicates that there is either no relationship, and I've just said it. 0 means no relationship, so 1 means there is a strong relationship. So if I look at this, it does not make sense. A positive linear relationship between the two means that when one variable increases, the other does. If x increases, y increases in this, and this we call it a positive relationship. So that will be correct. R closer to -1 states that positive. We know that a -1 should be a negative relationship. I'm not gonna go much into that. Happy?
Yes.
Okay, also the second one, also it looks at, oh, this is the linear regression. And here we're looking for the standard error of the estimate, which is the SSE. So if you don't know the the formula for the standard error. We go to the formulas. We can use this as a standard error formula, or we can use this is the other formula you can use for the standard error for the Y estimate. So if I go back there, in terms of the regression line, it makes it a little bit tricky because then the error estimate we didn't cover this in class. The best way it's going to take us longer to calculate. So what you do, I'm trying to look for a simpler formula for you to use. Because we can use the alternatively 1 minus r squared times n1 and n minus 2. There is not so much that I can show you in terms of the formulas, but then you have no choice to use the last formula that I showed you. So let's go back to that formula and write it down. This is the formula you need to use, unless if you can find a simpler formula. I'm not going to calculate it now. So which is n1 times your standard deviation or your variance minus your variance, the coefficient of covariance over your variance of x2. That's the formula you have, but there should be a simpler formula that you can use as well. Let me see.
Sorry, where you were now, Mrs. Boy.
Yeah.
I'm not sure if this is correct, the way I looked at it. But the screen we're on now, I use the y values minus expected y values squared, which gives us the SSE.
This one, you use this one.
Yes, and then after that, I use the standard error formula. If you scroll to the next page, the one on the right, the one that you've circled, the one on the right.
This one.
No, next to it on the right.
This one.
Yeah. I found it in the textbook. They've got it.
Yeah.
SE is equal to the square root. They've got a different sign though. It says SE instead of SY in the textbook. I'm not sure if that's correct, because in the textbook it shows standard error of estimate is SE is equal to the square root of SSE divided by n minus 2. Because then I get option number 1 as the answer.
Okay. Yeah. Yeah, you will have to go and work it out. I'm not gonna work it out here because of time as well. Going. So it's those two formulas. So you used the one that said SSE is equals to the sum of your Y value minus your estimated value, which is 3 minus 4 times squared. Is that what you used?
Yes.
And then you went and you used Y is equals to the square root of your SSE divided by n minus 2.
Yep.
You can still use that. Yes, you can. And then you get option number
1.
Okay, so we were on number 18. We left with 15 minutes. You will have to answer some of the questions on your own then as well. This is your this is Wilkins rank sum test. Sorry. They want you to calculate the test statistic here. So I think in the next 15 minutes, I'm just going to give you the hints on how to answer some of these questions as well. So they're asking you to calculate the test statistic. Remember, the test statistic is your T1, where you have the smallest sample size. So your test statistic for this one will be T1, which is the sum of your ranks. So what you will do with this one is you're going to order this in terms of the values and give them the ranking. And then once you are done, then you sum each one of them. The T1 will come from the sum of those ranks, and that will be your test statistic for T1. So it will be the sum ranks, the rank of sample size 1. And then question 20, they're giving you T1 and they give you what the random sample size is and the mean, and then they're asking you all these questions. So the mean your mean will be your n1 plus n1 times n plus 1 divided by 2. You will use that formula to calculate your expected mean. I'm using the wrong one. That is to answer number 1. The standard deviation will be n1 plus n2, the square root of n1, n2 times 1, n plus 1. Oh, wait, sorry, I'm using the wrong one. We need to be using the sum ranks. Yeah, sorry. This is the sum ranks. This is this. And then you will calculate your standard deviation. The square root of n1, n2 times n plus 1 divided by, I think it's divided by 12. And then you can calculate the Z. This is the critical value. So you will go find the critical value because it's alpha divided by 2. You go because this is a left, shift to the left. So it's a one-sided test. You're going to use Z for the critical value. You'll use Z alpha, which is 0, your Z 0,05. You go to the table. And remember at the bottom, if I go to this one, your Z, regardless of whether it's Z alpha divided by 2, so it's 0,05. The critical value is 1,645. So on this one, you can just assume that was correct. So the others you still need to calculate. Then you need to calculate the Z statistic. And your Z statistic, you use the formula. Is your T1 minus your mean. So to calculate the Z test statistic, you will say T1 minus, so you are given your T1 minus your expected divided by the standard deviation. And that should give you that the test statistic. And then you can decide whether are you rejecting the null hypothesis based on alpha level of 5. So you will have one region of rejection because it says left. Oh, sorry, left distribution. So it's not this side. It will be this side because it says it's left. So it will be the left side. And your region of rejection will be there and you can reject. And this question 20, we did it in class anyway. So you can also go to the Wilkinson test section where we were doing the Wilkinson and we did this question in class. And also the following, it also the Wilkinson. So here you given the positive and the negatives. Here we're going to only use the positive differences to calculate the, to calculate the standard test statistic. So we're going to use the Z because this is rank sum signed. So this is rank sign, not rank sum, rank sign test. So where we used only the positive and you will calculate the test statistic by using the Z value. So here you will use Z stat, which is given by your Z is given by T minus the expected value divided by the standard, still the same, T minus the expected value divided by the standard deviation, where your expected value for this one will be different. Here, your expected value will be n times n plus 1 divided by 4. N times n plus 1 divide by 4. And your standard error or your standard deviation will be given by the square root of n times n plus 1 times n2 divided by 24. Sorry, yeah, made a mistake here. It should be divided by 4. And this is n times n plus 1 times 2n plus 1 divided by 24. And those will be your standard. You substitute into this. Your t will be the difference. Remember, it will be the positive difference, which is 17. That is your t. So this will be your t and your t, and then you calculate your expected value using your n. And then the next one, it's also a rank sign test. Also, they give you the positive some value with your n, and you can follow the same concept we use there. And then go find the critical value, because this is a z. So critical value for z, it will also be z alpha, and you go use your z table. Okay, and question 23. Oh, sorry. What I'm missing here is after you have calculated your z test, you will go and calculate your z test using the same formula as this one that we used above. In the same formula, that formula, you will use this to go to the table to go find your p-value. You go to the table to find the p-value. Where on the table? You will go to the Z standardized normal distribution table, which is this table. Remember, if the answer is positive, you're going to subtract from 1. If the answer is negative, you just come here and look for the p-value, and that will be your answer. And that is your question 22. Question 23, in the last 5 minutes that are left, which is the third last question. This is, remember, this is time series. So here they're asking you if we are using the smooth time series. We did this the last time in class as well. And the weighting is 0.8. What will be for 1992, which is this? We did this in class. So if you want to see how we calculated this, you can go to the last session we did on time series. This was one of the exercises that we did in class. So we did exactly this exercise. So I'm not going to go into detail on this one. We also did this one in class. So on this one, it's asking for the SSE. So remember your SSE, which is your sum of your y value minus your forecasted value squared. So you're going to say this minus this, 10.46, we did this in class, 10.46 minus 10.81 squared plus 10.86 minus 10.85 squared plus until you do all of them. And then you're going to add the answer and go find the option here. So we did this question in class, so I don't have to do it and explain it even further. So go look at the time series video. The last one as well, we did this in class when we were doing the time series. So all of these questions, we've covered them in detail in class. So here as well, remember this is T1. So you will have to do until, what is 2008 minus 1991. I think it was 17, and then you add 1, it's 18 years. So it was 2008 minus 1991. Yeah, it's 18 years, which is 17 plus 1, which makes it 18 years. So what we said was our t will be equals to 18. So you're going to say y hat is equals to 1,200 minus 35 times 18, and that should give you your answer. We did this in class as well. So if you want to know in detail, you will have to look at what we did in class. And with that, it leaves us with 2 minutes for me to say thank you for being part of the session. Thank you for participating and for having 6 weeks of being together online. And I wish you all the best with your next coming exam. Remember, you still can request one-on-one sessions with me by sending an email to CT and TAT before your exam date. Don't send it the day before your exam and ask me, because we need to plan for my availability as well. Otherwise, thank you guys and all the best.
Thank you.
Thank you.